Okay, so in the second section of 6.6, we're going to be simplifying up these expressions with rational exponents, and we're going to use the properties we learned. This should be in 5.1. So let me flip you back real quick to what I'm talking about. So it's the very first section of 5.1. I'm sorry, the very first section of chapter 5, and we had all of these properties. So just to run through them really quick, if you've got a base and two separate exponents, you add them. Quotient, you subtract the properties. Anything negative, remember, gets flipped, or vice versa. If it's in the denominator, it gets flipped up. If you've got a power raised to a power, you multiply them. Anything with multiplication or division on the inside, you can distribute that property to both pieces. And then anything raised to the 0 power is 1. So we're going to be using all those same properties. If you lose track of any of them, just feel free to flip to this section 5.1. For now, we're going to simplify up some of these sections. So two really important things to remember. Rule number 1, any negative exponents get flipped. So if they were already in the numerator, they get flipped down. If they were in the denominator, they get flipped up. But either way, they get flipped. And then second rule is anytime that you have something in the denominator, any exponents in the denominator must be positive integers. Okay, so any in the denominator must be positive integers. So they must be positive just because of this rule right here. Anything negative would get flipped. And they must be integers because any fractions represent some sort of root, square root, cube root, whatever, and we're not allowed to have roots in the denominator. It's got to be positive and it's got to be an integer. So let's practice some of these properties here. So example 4, part A. Remember the rules that I just flipped and showed you. If we have the same base and then two separate powers, one of our properties tells us that we add those powers together. So we've got y, our new power will be 1/7 plus 4/7. Since they have the same denominator already, we can just add them together and we end up with 5/7. 5/7 doesn't reduce. That's really about all that you could do for your final answer, is you would just leave it like that. X to the negative 2/3, if we're following some of these rules, negative exponents get flipped. So we are going to write that as 1 over x to the 2/3, but if you're following the second rule, any exponents in the denominator have to be positive integers. So this is now positive, but it's not an integer. So what we have to do is basically like rationalizing the denominator. We have to make sure that we have a positive integer in the denominator. So if we want this to go from 2/3 up to 1, we would multiply in an x to the 1/3. So now our denominator will be taken care of because we'll add those exponents together and we'll end up with just a power of 1. But remember, you cannot just multiply the denominator without also multiplying the numerator. So we're multiplying in what we call just a fancy 1 here. Same thing, numerator and denominator. So numerator, 1 times x to the 1/3 is just x to the 1/3. And then here, remember, just like this property, I add 2/3 plus 1/3, and I get 3/3, which is just 1. So that is now just an x. So now I'm following both of the rules that I have here. So these are my final answers for both of these parts. All right, so let's this last one. One other rule to keep in mind, remember to use the least index possible. What that means is like if something was written as a 4th root, but you could actually simplify it, you should do that. So we'll see an example right here. So 6th root of 16, and then over the cubed root of 2. So we've got a lot of simplifying that we can do here. So first of all, 16 is a power of 2, so we're going to rewrite it that way. So we've got 2 to the 4th. That's what 16 is written as. So we've got the 6th root of 2 to the 4th and then over the cube root of 2. So just to help simplify, I'm going to write those exponents as fractions. So remember, the 6th root of 2 to the 4th means you can write 2 to the 4/6 power. So any index just becomes part of the fraction when you're doing these. And then this 2 to the 1/3 is the cube root power. All right, so let's keep simplifying. This 2 to the 4/6 will reduce down to, this is a 2/3. 4/6 just reduces down to 2/3. And then we've got 2 to the 1/3. So now finally we can use one of our properties that tells us if we've got the same base, we can subtract. So subtracting lucky for us, these have the same denominator, so I can just very easily simplify that to 2 to the 1/3. So that's the same thing as the cube root of 2. You can write it as the cube root of 2 if you want it, or you can just leave it as 2 to the 1/3, whichever you want to do. All right, this one here, same sort of thing. We are going to write 4 as 2 squared and then see how that simplifies. Okay, and then remember that 6th power means that we're taking the whole thing and raising it to the 1/6. 6th root is the same as the 1 over 6 power. So now I've got another property that tells me I can distribute that 1/6. So 2, I can multiply 2 times 1/6, and I get 2/6 as my power. And then times x to the, and then 4 times 1/6 would be 4/6. So I can keep on simplifying. So I've got 2 to the 1/3, because that power reduces down. Same thing with x to the 2/3. Okay, so now see how they both have that 3 in the denominator? That means they're both cube rooted. So you could leave it like this, same thing like we did here, but I'm going to show you just a different way that we can simplify. So 2 to the 1/3 means I've got a 2 under a cube root. X to the 2/3 means we've got an x squared under a cube root. So this is the most simplified that you can write something like that. So just kind of reducing down this power into this. Okay, last one here. This is like a rationalizing the denominator thing. So I've got y to the 1/2 minus 1. That's not a positive integer, so I need to change it. And what I'm going to do is something that I did in the previous section, and I can multiply top and bottom by the conjugate. So the conjugate of y to the 1/2 minus 1 is y to the 1/2 plus 1. So top and bottom, same thing. Okay, so I'm going to FOIL both pieces. So y to the 1/2 times y to the 1/2. Remember, you add those exponents. 1/2 plus 1/2 would be 1. So that's just y to the first, or y. Outside, y to the 1/2 times 1. Inside, another y to the 1/2 times 1. And then 1 times 1 for the last. And then the denominator, very similar. First, 1/2 plus 1/2, I add those exponents and I get 1. Y to the 1/2 times positive 1. Inside is y to the 1/2 times negative 1. And last is negative 1 times positive 1. Okay, so you'll see these cancel, which happens every time we use the conjugate. It gets us to simplify our denominator. And then in the numerator, we have y. There are 2 of these y to the 1/2, and then a plus 1. And my denominator is just a nice y minus 1. So these two things are equivalent. I just had to change the way it was written because I'm not allowed to have that 1/2 in the denominator. So this is a quick just summary of all of the simplifications that you should be making. You should have no negative exponents, no exponents that are not positive integers. We've been talking about both of these. Not a complex fraction, meaning a fraction of fractions. And then the index is the least number possible. So we did that with something like part B.